Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, we're continuing our look at climate change projections, specifically projections of regional interest to us here in North America and the American West. So, we've had a look at the global temperature projections through the end of this century, and we've found an enormous spread. The reason for this spread is uncertainty in how we humans will choose to move forward, low carbon or high carbon. And from the standpoint of risk, it's pretty clear there's a sweeping difference between the two. So to further convey a sense of the choice before us, let's have a look at three more projections of regional interest. And we'll start with regional temperatures. Remember, models are physics. And here's what the physics has to say about the evolution of temperatures for North America under a high carbon scenario. That's the scenario we're currently most closely tracking. Now again, these are projections for temperature change. The Arctic isn't getting warmer than Arizona, but it is warming faster. The darker the red, the more the warming. And with the high Arctic warming as much as 25 degrees Fahrenheit by century's end. Now, by contrast, this is century's end under a low emissions path. It's still significant warming, but dramatically different than the high carbon scenario. Putting them side by side is helpful. In Utah, for example, under a low emissions scenario, we can expect an average temperature rise of perhaps 5 degrees Fahrenheit this century, which is roughly the warming we've already seen yet again, so not insignificant. But that number rises to perhaps 13 degrees Fahrenheit on a high emissions path, again, the path we're currently following. Next, we'll look at snowpack projections in the Rockies, which combine both temperature and precipitation projections. Specifically, what we're looking at here are spring conditions, March and April, when our snowpack has historically been at its maximum, ready to start filling reservoirs and irrigating fields. I'll focus you here on our part of the Rockies and point out that the darker blues are deeper snowpack, the lighter grays, thinner snowpack. We'll start with observations over the past 60 years, beginning in 1950. Followed by projections for the next 85 years under a high carbon scenario, again, the scenario we're currently following. As we start the animation, the actual observations certainly show variability from year to year, but there's always a significant spring snowpack. Moving into projections, a downward trend becomes clear, and as we move past mid-century, we find substantially thinning snowpack disappearing for all practical purposes in about 5 decades. This has relevance for many reasons, but most importantly because most Utahns get most of their water from melting snow. Lastly, also of high importance is soil moisture, arising from a combination of temperature, precipitation, and other variables like vegetative cover and soil condition. At this time, we'll begin with a moderate emissions scenario where deeper browns mean more drying, deeper blues mean more moistening. In this case, we see significant drying across most of the United States and Central America through mid-century, stabilizing afterwards as carbon emissions presumably come down. Under a high emissions scenario, again the scenario we're currently following, here again, steady drying from the US and Central America through mid-century, which then greatly intensifies for the second half of the century as temperatures continue to rise. The agricultural scientists, ecologists, and economists who assess these results categorize the moderate emissions scenario as serious and the high emissions scenario as catastrophic. And so again, two dramatically different levels of risk, and again, largely dependent on the choices we as a society are making. So projections of rising temperatures, declining snowpack, intensification of the water cycle, drying soil, and all the rest. Now, this brings us to the point of interpreting this science from the standpoint of risk. So I've already stated that science has assessed the risk to humans as extreme. And here are quotes from two prominent climate change scientists that underscore this point. Lonnie Thompson, a distinguished glaciologist, and Kevin Anderson, one of the world's preeminent carbon modelers. Now, their words, clear and present danger, incompatible with an organized global community, beyond adaptation, devastating, not stable, may seem extreme or even shrill. I'll simply state that these sentiments are common within the climate change science community. So the state of the scientific story at this point, then, is this. Dangerous climate disruption is underway, as defined by a 2 degrees Celsius rise in global average temperature, where we've already risen half of that, and catastrophic climate disruption, defined as more than 4 degrees of warming, is probable this century on our current emissions trajectory. Sobering stuff, and it raises the critical question of mitigating this risk, which we'll examine in the next episode. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.